4B, the power of compounding. In chapter 4, we will be talking about a few different topics related to personal finance, related to money, that topics of money that you will be dealing with in real life. We are going to be starting with interest. And the very first thing that we're going to start with is something called simple interest. And in simple interest, we are imagining that we put money in the bank, and suppose that the bank pay us 5% interest every year. And at the end of the year, the bank will give us $50 of interest. And suppose the interest is sent to you instead of giving you the interest and leaving it in the account. So we got $50 in our first year, and we use that for Christmas shopping. And every year, because we get 5% every year we'll get $50. So if I leave my $1,000 in the bank for 3 years, then at the end of the first year, we get $50. At the end of the second year, we get $50. At the end of the third year, we get $50 again. In total, we'll get $50 3 times. So 3 times 50 give us $150. This is called simple interest. And this is what happens if we receive the interest and it's taken out of the account, and we receive the same amount of interest every term. The $1,000 that we start with, that's called the principal. We know that in our bank account, we don't really have simple interest, because when the bank pays us interest, the interest is kept in the account. And instead of having $1,000 at the start and having $1,000 throughout all these different years, our money is going to build up more and more. But in real life, there are a few different cases where we use simple interest. One of the main situations that we use simple interest is in something called bonds. Bonds is a form of borrowing money or lending money to someone else. So the government, Canadian government, for example, typically spends more money than it receives. So every year when it collects tax, and then later on when it spends money to pay the Canadian employees that work for the government, or pay for all these different things that the government will have to spend money on, typically in Canada, the government spends more than they take in. Since they spend more than the tax they collected, they will have to borrow money. And instead of saying that that Canada borrow money from us, it's set up another way around. It's set up in a way where we buy something called bonds, and when we purchase bonds, that means we lend $5,000 to the government, and the government promised to pay back the $5,000 as well as interest along the way. You'll notice that bonds from many years ago, it's given to us as a piece of document. In this case, when we purchase $5,000 worth of bonds, we lend Canada $5,000. The government promised to pay us back at the maturity date here on June 1st, 2015. So on June 1st, 2015, Canada will give back the $5,000 that they borrowed. Every half a year, on June 1st and December 1st, Canada will pay interest to us. And the interest is, back in the days, it's quite high. It's 11.25%. So you'll notice there will be coupons that looks like this. And on June 1st and on December 1st of each year, you take the piece of paper, you go to the bank, and they will give you the interest on the $5,000. In this case, it's always 281.25. That's 11.25%. These days, bonds are done electronically. So they are done over the internet, and we no longer get pieces of paper that's given to us like this. But bonds still exist. We can still purchase bonds. And when we purchase bonds, we lend out money to government, Canadian government. We can lend out money to provincial government like BC government, Ontario government. We can also purchase bonds to lend out money to big companies like all the different banks in Canada, like the pipeline companies in Canada, or the oil and gas companies in Canada. We can also purchase bonds to lend money out to the big telecoms, to the companies that operate our cell phones, like TELUS, Bell, Rogers. The way we deal with bonds is that the interest that's paid in bonds are simple interest. So they will pay us, and they typically pay it to a different account so that the money that they borrow or the money that we lend out stays $2,000. If we lend out $2,000, if we buy a $2,000 worth of bond, and the interest rate is 3% per year, in 5 years, okay, the interest that we will get paid is this. First, we calculate how much we receive every year. So every year we get 3% of the 2,000. 2,000 times 3%. 3% is 0.03. And remember, we divided by 100. That will give us $60. That will give us $60 every year. Since we are lending out money for 5 years, we take 60, we multiply by 5, and we get 300. A different type of situation is called compound interest. In compound interest, we keep our money in the account, and instead of receiving the interest separately, the interest will be put into the bank account, and instead of having just $1,000 all the way throughout our investment, all the way throughout leaving the money with the bank, the $1,000 is going to grow bigger and bigger. So for example, if the interest is 5%, at the end of the first year, we get 5% more, or 1,000 times 5%, that's $50. And what we'll do is now we'll leave the $50 in the bank. The bank, inside the bank, we now have 1,000 plus 50, so $1,050. On the second year, we'll get more interest because instead of $1,000, we have more money. The more money we have will give us more interest. And when I multiply that by 5% or 0.05, we get 52.5. So it's a little bit more money on the second year. And it's a little bit more money because now we have $50 more. We have the interest that we pay, that we got paid the year before. So the interest that we got before, we are able to make a little bit more. It's interest on interest. At the end of the second year, we have 1050, what we start with, plus the interest, 1102.5. And we can do this again on the third year. We multiply by 5% again. We add it up again, and we get a little bit more still. At the end of the third year, we have 55.13. It's a little bit more than the 52.5 that we got last year. So at the end, it's not $11.50. With compound interest, we got $7.63 more. And that's the interest on interest. If we have to do compound interest over and over again, it's a little bit difficult. If we keep doing if we keep trying to find out what the interest is, and then adding that onto the principal, adding that to whatever is in the account. So instead of multiplying and then adding, there's a shortcut. Remember that getting 5% more is the same as 105% of the original number. Right? We got 5% more, so we have the original plus 5%, so 105. The original amount is 100, right? So 100 plus 5%, 105. When we do the calculation, remember, we never really use the decimal, we never use the percentage form. We always convert the percentage form into a decimal number, into 1.05. And what that will do is we can just simply take 1,000 multiplied by 1.05, and we get to our answer in one step. If I have to find the amount after 2 years, the accumulated amount after 2 years, I will just multiply 105% or 1.05 2 times, right? I'll multiply by 1.05, multiply by 1.05 again. And this is really easy to do because if I multiply the same number again, it's to the power of 2. 3 years, it's to the power of 3. That makes the calculation a lot easier without having to multiply and then add and then multiply, add and multiply, add. Here we only multiply. And if we figure out what to multiply, 1.05 in this case, if I have to multiply multiple times, I just use the exponentials. The formula looks like this. On the test, I'll be providing the formula on the exam, but there will be no explanation of what the variables represent, what the symbols represent. You have to know what the symbol represents. So suppose we're trying to find out what's the total after 3 years. That's the A that we're trying to find. A at the end will be 1157.63. How do we do that? The principal, the money that we start with is 1,000. And we take 1, and we take our 5%. So 5% is 0.05. And we do this for 3 years, so y is 3. Now, in this case, we are calculating interest at the end of each year. So every year we do interest 1 time. So n is 1. And here we have 1 times 3. So you'll notice we ended up having 1,000 multiplied by, and over here in the bracket inside, if you put it into your calculator, or if you do a little bit of algebra, you'll find that everything in here works out to be 1.05. And everything in the exponent, 1 times 3, that's the 3. And that's where our formula, that's how we use our formula to get to the answer. When we use our formula is able to tell us that this is what we have to do to find the total after 3 years. Now let's try to use our formula in this example. In this example, we start with $2,000. So the P that we have is 2,000. The 3% rate, we have to change that from decimal form, from percentage form to decimal form. And we convert percentage form to decimal form by dividing it by 100. So 3% divided by 100 turns into 0.03. If we save up for 5 years, we put the 5 in Y. So it's 5 over here. We are compounding annually, so that means we are finding interest one time every year. And so N is 1. You can try to put everything in your calculator. If you try to put everything in your calculator, remember to put in the brackets. Now this part up here, this is the exponent. So you will have to use the exponent button in order to do that. To use the exponent button, typically calculator have buttons that either look like this, x to the power of y, or some calculator will simply have a little chevron button like that. And these buttons are what we use to calculate the, to do the exponent. Now, for most students, it's a little bit easier if we find out what's inside the bracket first. Okay, so for most students, it's easier to do the bracket separately, and this should give us 2,000 times 1.03 to the power of 5. And in your calculator, you will put these numbers in. You will do 2,000 multiplied by 1.03. And for the exponent, we have to use the exponent button over here to the power of 5. And this will give us our result. Oops. Now you'll notice the answer here, we rounded to 2 decimal places in this 2 decimal places in this example. On the test, we'll tell you how many decimal places to round to. Now notice, compare that to the simple interest example before. In simple interest, we got $300 worth of interest in total. Here we get $18.55 more. What I want to show you in this picture here is that in compound interest, you notice the money grows exponentially. So this is very good if you start savings really early on. As the year progresses, as you get older and older, the growth gets bigger and bigger because you're going to have more and more money. Now, what happens if we have interest that gets paid more than once a year? In this particular example, we start with $2,000, and here we are compounding monthly. So the only difference is that instead of getting paid interest just one time, just once every year, we're going to get interest paid 12 times a year. Right? There are 12 months in total. So in this case, N is 12. And you'll notice we have to use the 12 in 2 different places. We use the 12 up in the exponent because there are 5 years, and each year there are 12 months. So in total, it's 5 times 12, 60 times where we're going to get interest. Right? We're going to get interest paid 60 times. So like I said before, I like to multiply, I like to do the calculations with each bracket separately. So 5 times 12 is 60. You can do that in your calculator. 1 plus 0.03 over 12. We can also use our calculator. That should give you 1.0025. And we will put this into our calculator, 2,000 times 1.0025 to the power of 60, and that will get you your answer. Oops. Now, the reason why the percentage, the 3% here has to be divided by 12 is because if we are giving you interest every month, you're not going to get 3% every month, right? Because if you get 3% every month and you get 3% 12 times in a year, it's not 3% anymore. So what we're going to do is we're going to take 3%, you get 3% for the whole year. So then each month you get to, you only get 3% divided by 12, right? You only get a little bit of the 3% every year. What we'll notice is that if we do compound interest, if we are compounded more than one time every year, so that could be compounded monthly, that could be compounded quarterly, so quarterly means 4 times a year, or it can be compounded semi-annually, semi-annually means twice a year, or it can be compounded every day. Now, in these examples, we're going to get interest more than one time every year. And we know if we get interest more than one, every time we get interest, and every time we get paid interest, the interest is going to start to grow, right? It's going to grow on itself. We're going to get interest on interest. So when I take 3% and I divide it by 12, the actual amount that we get is not going to be 3% at the end of the year. Why? Because the very first month, we got a little bit of interest, and that interest is going to get extra interest money every month in February, in March, in April, every month throughout the rest of the year. So we're going to get a little bit more than 3% because the interest that we get at the beginning of the year, they're going to grow a little bit until the end of the year. How do we find out how much more? Well, we have to actually do the calculation. We have to do the calculation and we have to find out if I compound it monthly at the end of 1 year. So that's why I use 1 here. The year is 1. How much money will I have? And we'll have 2060.83. And if we try to find the percentage change, the relative change, you'll notice I subtract the 2,000. I find that I have $60 more, $60.83 more. Dividing that by 2,000 is a little bit more than 3%. And it makes sense because the interest that I got on the first month, the second month, the third month is able to grow the rest of the year. And I'm going to get a little bit more than 3% because of that, because of the interest growing and getting more interest back. So in the end, the yield is the actual, the word yield up here is the actual amount that we can get. The actual amount, the actual percentage that we get is 3.042. All right, so this is the difference between the APR and the APY. So if you use credit card has an APR. But when you actually use the credit card, you're going, and if you owe money on the credit card, you're going to get interest every month, right? Every month. And at the end, if you let the interest grow every month, the rate, the effective rate, the actual rate, and we call that the actual rate, the annual percentage yield. The yield is actually going to be higher. So we're going to have to pay higher than the APR when we pay back our credit card debt. And when you go to the bank and you save money and they give you interest every month or every half a month, that's the annual percentage yield is also higher. We get a little bit more that way. Now you can see here, to find the annual percentage yield, we use the same formula that we did before. You only have to remember that we put in 1 year and we have to do the relative change. So let's try to find the annual percentage yield for something that is compounded daily. If we compound it daily, we get interest 365 times in a year. So n in this case is 365. Since we want to find the annual percentage yield, annual means every year, we want y to be equal to 1. We put this into our formula, and you'll notice we don't really care about what the P is. All we care about is what's the percentage that we get that we have to multiply at the end. Now you can make up a number. You can say I start with 1,000 or I start with 2,000, and then do the relative change later. But what you'll notice is that in this case, right, we get 1.030453 more. So the difference, the extra, is the 0.030453, right? The extra part is that part. And that's 3.0453%. How do I know that? Because to change from decimal form into percentage form, I multiply by 100. And we can also do it this way, and doing it this way is faster. So what you can also remember is that we are only using that part of the formula. And after I find out what the number is, I need to subtract it by 1, because 1 is the original number that we added on. And if I subtract it by 1, I find out how much more. And I'll have 0.03, and I just need to convert that into percentages. Now, when we deal with money, things will grow at a certain compounding rate, right? We'll say, well, the bank will decide at the end of the year, or at the end of every half a year, or at the end of every month, or at the end of every day, we're going to give you interest. We're going to do compounding. But if we have something that's growing in life, like in nature, let's say we have animals growing, or people, new babies getting born, or we might have bacteria or virus that's growing. Now, and when we have animals, right? Let's say we have animals growing, or humans, the population growing. We're not saying that, oh, okay, let's hold up. Okay, let's wait until end of the day. Let's wait until end of the day. That's when we're doing all the births. So you can only have your baby born at the end of the day, 12 a.m. All right, that's the only time. No, we don't do that, right? Babies can be born any single instant, any single instant. So we're growing all the time. We're growing continuously. And when we're growing continuously, what you will see is that as we grow, as we compound more and more, eventually we reach a limit. We reach a limit. We reach a number, and that's called continuous compounding. And in continuous compounding, we use the symbol E. And E is a special number. It's like pi, and it will be in your calculator, and you will have to use a special key. Now we'll talk about this. We'll have questions on continuous compounding, but we're not going to have exam questions on continuous compounding. Okay? Because we're dealing mostly with money in this chapter. Continuous compounding is something that is more for nature. When you're dealing with population, when you're studying diseases, when you're studying zoology, studying animal plants. We'll still do an example here. Here, we're trying to grow continuously. We're trying to compound continuously. How much will we have? Well, in this case, we have to use the symbol E. When I put it into my calculator, I do 2,000. And then let's see what kind of function we have. Here we have the symbol E over here. So we'll do multiply by E, and then to the power. And when we do the power, if you haven't done the bracket before already separately, then you have to put in the bracket. Okay, so otherwise you'll make a mistake. And here we'll close the bracket and we'll press equal sign. And you'll notice we just get a slightly different number, a slightly bigger number. You'll notice that as we compound more and more often, we'll get a little bit more money, and we'll end up getting 23.67 extra after 5 years. That's the maximum that we can get to.